This is the class activity for acceleration calculations. So the purpose of this activity is to practice using the equations to calculate acceleration to solve for the unknown variable. So you can see here, there's the equation to find acceleration and the acceleration triangle. So there are references. Of course, there's going to be this video. There's also a video that helps you with just talking about position, velocity, acceleration, and there is a video that helps calculating acceleration that shows how to do that. All right, so the first part are oil drop diagrams. So the car is driving and the oil is dripping at a constant rate. So the car pictured is in the ending position, right? So you imagine a car driving and it's dripping oil at a constant rate. So we're looking at those drops. Now, all of these questions must be answered in order to get it correct. So let's take a look at this first one, right? So we know that this car, it looks like these drops are getting farther and farther apart. So it is accelerating, and if it's moving to the right, it is speeding up. What is the direction of the object's velocity? So velocity, just think about what direction is this object moving in? So it's moving towards the positive direction. Now, acceleration is a little bit tricky, right? It has to do with the direction of the velocity and what it's doing. So there is a little hint here, and it says, well, if the object is speeding up, the acceleration will be in the same direction as the velocity. So it is speeding up. We already have that, and the direction of the velocity is positive, so that means the acceleration must be in the positive direction as well. So there are 6 of these, basically the 6 different scenarios that you can have. Now the next part is calculating acceleration. So use the following, use the equation to calculate acceleration. So this equation is up here. So let's just do the first one together. Calculate the acceleration of Josh riding his bicycle in a straight line that speeds up from 4 meters per second to 6 meters per second in 5 seconds. So the first thing is, I want to ask myself, what is this question asking us to find? So if I look at my little equation triangle up here, I cover up acceleration, and the acceleration is going to equal the final velocity minus the initial velocity divided by time. Notice it already turned green, right? So this is just because I want to make sure that you're using the correct equation. Now, in order for the value or for the variables to turn green, you have to get both the value and the unit correct. And points will be awarded when you get the whole thing. So let's take a look at this. Now, final and initial velocity, think about telling a story, right? The final velocity is how fast is that object traveling at the end of this story. And the initial velocity is how fast was it going at the beginning of that story. So let's just do these, right? So the acceleration, riding on a bike that speeds up from 4 to 6. So let's just do the initial velocity. So this speeds up from 4, and the velocity, the unit is meters per second. And the final velocity, it speeds up to 6 meters per second, right? Now I also know the time, right? So the time is going to be, this takes place over 5 seconds. Now the last thing I have to do is just plug in all these variables. I know they're correct because they turned green, and I know the equation because that's green too. So I plug everything in and I calculate acceleration. And if you need help, there's a little hint here. Cover up the unknown variable in this acceleration, and it even tells you what the unknown is. The unknown is acceleration. So now I just, let's see, it's final velocity minus the initial velocity. 6 minus 4 is 2, right? And 2 divided by 5 is going to be 0.4 meters per second squared. Right? Meters per second squared. And now it turned green, and I got points. So there are several questions about this. Just follow that step, use those hints, and you'll be able to get these problems. So once again, this is the class activity in order to calculate acceleration.